Hello, my name is Daniel, and today we'll be going through the AMC 12A from the year 2016, so let's get started. First problem, what is the value of this thing? Okay, so we can immediately see that we can divide this by 9 factorial on the numerator and the denominator. This gives us all over 1, and then 11 times 10 minus 10, which is just 10 times 10, which is 100. So 100 is our answer, it's B. Number 2, for what value of x does this equal 1000 to the 5th power? Okay, so this is all going to be the left-hand side. That's going to be 10 to the x plus 4x, so that's just 10 to the 5x power, equals 1000 to the 5 power, that's just 10 to the 15 power. So 5x equals 15, x equals 3, and there is our answer, it's C. Number 3, the remainder can be defined for all real numbers x and y with y is not 0 by remainder of x and y equals this thing, where the floor of x over y denotes the greatest integer less than or equal to floor, over x over y. What is the value of this thing? Okay, so we can just plug them in there. So that's going to give us 3 over 8 plus 2 over 5 times the floor of 3 over 8 over negative 2 over 5. And so this is going to give us, so this thing, that's going to be equal to, so that's going to be all equal to minus 15 over 16. So this is going to be equal to 3 over 8 plus 2 over 5 times minus 1. So this is just 3 over 8 minus, that's just 3 over 8 minus 2 over 5, which gives us all over 40. And then 15 minus 16, which equals minus 1 over 40. And there is our answer, it's B. Number 4, the mean, median, and mode of the 7 data values this thing are all equal to x. What is the value of x? Okay, so we don't need the median and mode, we just need the median because that just gives us everything. So 7x, so the mean is x, so that means 7x equals this thing all together. And if we just take out 1x from each, then that gives us that 6x. 6x, this is equal to 60 plus 100 plus 40 plus 50 plus 200 plus 90, which is, we have 300 like that, and then we have 400, and then we have 490, and then we have 530, right, so we have 540, so 6x is equal to 540, this means x is equal to 90, and just there's our answer, it's D. Number 5, Goldbach's conjecture states that every even integer greater than 2 can be written as the sum of two prime numbers. So far, no one has been able to prove that the conjecture is true, and no one has found a counterexample to show that the conjecture is false. What would a counterexample consist of? Okay, so if we just look at this conjecture, then this is like, if it's an even integer greater than 2, then it can be written as the sum of two prime numbers. So it's a and then b, let's say, then it's going to be if a, then B format. Then we want to have a counterexample. This is going to be something that's A, but not B. So that means that is going to be an even integer greater than 2, but it can't be written as the sum of two prime numbers. That is basically E. So that's our answer. Number 6, a triangular array of 2016 coins has 1 coin in the first row, 2 coins in the second row, 3 coins in the third row, up to n coins in the nth row. What is the sum of the digits of n? Okay, so 1 plus 2 plus 3 plus 4 plus all the way up to n. This is equal to, 2016. But then we know that this is just equal to all over 2, n times n plus 1. And this is 2016. That means n plus 1 equals 4032, and this is just equal to 63 times 64. Therefore, n is equal to 63, so 6 plus 3 equals 9. So 9 is our answer, it's D. Number 7, which of these describes the graph of this thing? Okay, so first we see that these two are equal. That means either this and this are equal, or that is just 0. So either x squared equals y squared, or x plus y plus 1 equals 0. But if it's this case, then that means it's either y equals x or y equals minus x. And then for this case, that's just when it's y equals negative x minus 1. So graphing these briefly, we can say that y equals x and y equals minus x is going to be like this and like that, going through the origin like that. And then y equals minus x minus 1, that's going to be like this. And so there are 3 lines that do not all pass through a common point. That is just D. It's D. Number 8, what is the area of the shaded region of the given 8x5 rectangle? Okay, so since it's an 8x5 rectangle, that means that this much is 5, so half of that like this, it's going to be, that's going to be 2.5. And since this whole thing is 8, that means half of that is going to be 4. And if we just draw a line from one end to the other diagonally, right? Diagonally from here to there, like that, then we are going to get 2 of these red triangles and 2 of these green triangles, right? So for the green triangles first, So there are going to be 2 times because there are 2 of them. And then since they're triangles, 1/2 times, and then the base is 1, so that's 1 times, this is the height, so it's 2.5. These 2 cancel, this is equal to 2.5. And then next for these ones, these are going to be equal to 2 times, because there's 2 of them, 1/2 because it's the triangle, times 1, that's this base right here, times this is the height, so that's 4. This is going to be cancelled, and 4. So if we just add them up, it's this plus this gives us 6.5. And this is our answer, it's D. Number 9, the 5 small shaded squares inside this unit square are congruent and have disjoint interiors. The midpoint of each side of the middle square coincides with one of the vertices of the other 4 small squares as shown. The common sign length is this, where A and B are positive integers. What is A plus B? Okay, so if we just say that this sign length, if that's A, so if we just say this is 2. So if that's 2, like that's just setting it as a random number, then this thing, that diagonal, that's going to be equal to root 2, right? So this is going to be root 2 since it's a unit square. So root 2 equals, and then we have to find these lengths according to if that's root 2. So then this would just be 2, and this would be 2 root 2, and this would be 2 root 2. So together, then that's going to be 2 plus 4 root 2. So root 2 actually is 2 plus 4 root 2 when we're saying that this is equal to 2. And so what that means is that if we want it to be 1, that's for this side length, that is going to be root 2 plus 4. So 4 plus root 2, then that becomes 1. We want this to be 2. So here, that means 4 plus root 2. That will have to be turned into 1. That means 1 will turn into 1 over 4 plus root 2. So since the side length is 2, 2 is going to be turned into 2 over 4 plus root 2, which is root 2 over 2 root 2 plus 1. So this is going to be equal to 4 minus root 2 over 7. So 4 and 7 are our A and B. So A plus B is going to be 4 plus 7 equals 11. And that is our answer. It's E. Number 10. 5 friends sat in a movie theater in a row containing 5 seats, numbered 1 to 5 from left to right. The directions left and right are from the point of view. So this is left and this is right. And then during the movie, Ada went to the lobby to get some popcorn. When she returned, she found that B had moved 2 seats to the right, Cece had moved 1 seat to the left, and Dee and Eddie had switched seats, leaving an end seat for Ada. In which seat had Ada been sitting before she got up? Okay, so if that was the end result, this was left for Ada. And then B had moved 2 seats to the right, and Cece had moved 1 seat to the left. Okay, so if B had moved 2 seats to the right, then that means she was in here somewhere. And that would be if B had come here and then B had moved like that. And then if B came here and then CC would have been here and then she would have gone like that to go like that. And then D and Eddie, they're just like this. And so this is the final configuration. If we just switch that around, then B is going to go like that. This is where they were before. And then D and Eddie, they just switched seats, so it's just E and D. And Sissy would have moved 1 seat like that, so it's C. Therefore, this was Ada's original seat, so it's second place. It's B. Number 11. Each of the 100 students in a certain summer camp can either sing, dance, or act. Some students have more than 1 talent, but no student has all 3 talents. There are 42 students who cannot sing, 65 who cannot dance, and 29 who cannot act. How many students have 2 of these talents? Okay, so if we draw a Venn diagram like this, and we have sing, dance, and act, then we're just going to label it A, B, C, D, E, F, G, like that. But then since no student has all 3 talents, that means C is just equal to 0, so we're just not going to consider C anything. And then there are 42 cannot sing, 65 cannot dance, and 29 cannot act. If we just write that out, and then this is sing, so cannot sing is E, F, G. E plus F plus G is equal to 42 students. And then 65 cannot dance, right? This is dance, so this much is dance. Not dancing is A, D, G. So A plus D plus G, that equals 65. Lastly, cannot act. That's just A plus B plus E. So A plus B plus E, that equals 29. So if we just add all of these up, that gives us A plus B plus D plus E plus F plus G. But then we have to do plus A plus E plus G one more time. This is going to be equal to 136. And since we know that this is the sum of everybody, no C because that's just 0. And this is going to be equal to 100. So that means A plus E plus G equals 136 minus 100, which is 36. And so how many students have 2 of these talents? That's going to be asking for BDF. So BDF, this is going to be 100 minus AEG minus 36. That's going to be 64. And that is our answer. It's E. Number 12, in ABC, AB is 6, BC is 7, and CA is 8. Point D lies on BC, and AD bisects BAC. Point E lies on AC, and BE bisects ABC. The bisectors intersect at F. What's the ratio AF to FD? Okay, so first thing, AB is 6, and then BC is 7, and then CA is 8, and then D lies on BC, and then AD bisects BAC, like that, and BE bisects ABC, right? So like that. So first thing that we can see, we see that this, so that bisected, so that means CD to DB, that is just 8 to 6. So this is 8 to 6, which is just basically 4 to 3. They add up to 7, that means their length actually is 4 and 3. So like that, that's going to give us 4 to 3. And now we can use this triangle to see AF to FD. That's going to be 6 to 3. So AF to FD, this is going to be equal to 6 to 3, which is 2 to 1. So 2 to 1 is our answer. It's C. Number 13, let n be a positive multiple of 5. 1 red ball and n green balls are arranged in a line in random order. Let Pn be the probability that at least 3 over 5 of the green balls are on the same side of the red ball. Observe that P5 equals 1 and Pn approaches 4 over 5 as n grows large. What's the sum of the digits of the least value of n such that Pn is less than 321 over 400? So let's try to visualize this. If n is a positive multiple of 5, let's say n is 5x. That means if we have like 15, 5 more like that, then we are going to be able to split it into 5 groups with each having x number of balls. So like that, like that. So these are 5 groups of 3 balls. This is when x equals 3. And so for Pn to not happen, so for at least 3 over 5 of the green balls on the same side of the red ball, for that to not happen, then the red ball has to go inside here, so either here or here. So that's just 2 ways. And if x equals 4, then the middle 4 are going to be like this, and the red ball is going to have to go somewhere between here. And so we're just doing complementary counting. If there are 5x in total, so there are 5x plus 1, 5x, right? 5x plus 1 ways where the red ball could go. Not caring about anything, there's 5x plus 1 ways. But then of those, the red ball has to go to n minus 2 ways. As you can see, if n is 4, then it can go 3 ways. If n is 3, it can go 2 ways, like that. So it goes x minus 1 ways. This is to not happen. So this is for Pn to not happen. Pn must be less than 321 over 400. That means this is 1 minus Pn. So this must be greater than 79 over 400. This is just basically 1 minus 321 over 400. And for this to happen, this means that 400 times x minus 1 is greater than 395x, because that's 79 times 5. And then plus 79. So this will give us that 5x is greater than 479. And so our smallest x, that's going to be x is greater than 479 over 5. So the smallest will be when it's 480. So x equals 480 over 5. And this is going to be equal to 96, right? So that's when x is equal to 96. So the n will be 5x, which is 480. And 480 is our number, so the sum of the digits is 4 plus 8 plus 0, which is 12. And so 12 is our answer. It's A. Problem number 14. Each vertex of a cube is to be labeled with an integer from 1 through 8, with each integer being used once, in such a way that the sum of the 4 numbers on the vertices of a face is the same for each face. Arrangements that can be obtained from each other through rotations of the cube are considered to be the same. How many different arrangements are possible? Okay, so basically we have integers from 1 to 8, so we have 1, 2, 3, 4, and then 5, 6, 7, 8. And if we have a cube like that, then each face will have to have numbers that add up to half of that, which is just these two will get 9, 9, 9, 9. So this is 18 times 4. So each face will have to have 18 times 2, which is 36. But then now we see that we can divide this into 4 of these columns, 4 of those columns, and 2 of these faces. And so we have 4 columns like that and 2 faces. What this is basically telling us is that we can have each of these pairs be one of the columns. So those pairs can be in either in one of these columns. So for example, it's gonna be like 1 8 and then like 1 8 and then like 4 7 or like 6 3, something like that. And so basically each pair is going to be each kind of pillar. Now what we have to see is that these things have to add up to 30. They have to add up to 36 also. So now if we just list them in pairs, we have 1, 2, 3, 4, 5, 6, 7, 8. These are the pairs. Then we have to choose one number from each pair so that they will add up to 36. And then if we do that, then we have 1, 7, 6, and 4. They will add up to 18, right? They will add up to 18. That means these 4 are going to be one of these, and then this, the amount that's left, that's going to be the other side. And so this is our only that's our only other combination. So our number of arrangements, those are going to be how we just put up these 1764, right? So is it going to be 1764, or is it going to be some other way, right? Like 1764 or something like that. So that's what we have to choose. And so now that is going to be equal to 3 factorial, because that's just 4 people on round table. So this is just basically going to be 6. And 6 choices is our answer. It's C. Number 15. Circles with centers P, Q, and R having radii 1, 2, and 3 respectively lie on the same side of line L and are tangent to L at P prime, Q prime, and R prime respectively, with Q prime between P prime and R prime. The circle with center Q is externally tangent to each of the other 2 circles. What is the area of the triangle PQR? So let's just basically first draw this. If we have a large line, and then we have our small circle, and then we have our medium-sized circle, tangent like that, and we have our large circle, tangent like that. Then those are going to be P, Q, and R like that. And then if we draw lines between their centers and everything, it's going to look something like that. So these are going to be the lines, right? This is going to be how they look. So this is P, this is Q, this is R, right? So this is P, Q, and R. So and this is P prime, Q prime, and R prime. We need the area of triangle PQR, which is you can see right here, but then this is a very, very small subtle triangle, right? I can't even draw it really well. So it's this PQR, that triangle over here. It looks like a line, but it's not. It's actually a triangle. Okay, so what we now have to do is use like lots of Pythagorean theorem. We have Pythagorean for that, one for that, and one for this P and R. And the radii are 1, 2, 3 respectively. And so we know that, this side is 3 and this side is 1, right? Because this is 3, 2, 1. That means this is just 1, 1, 1. Right? And then we know that this side is 5. And so now if we do Pythagorean theorem for this triangle, then we can get that this length, that's just equal to root 3 squared minus 1 squared, which is root 8. So that's 2 root 2. And then now for this part, that is just going to be, that's going to be this part. That's going to be equal to root 5 squared 25 minus 1 squared, that's 1. So that's root 24. So that's root 24, which is 2 root 6. Now this whole thing, and so we can calculate these areas. So the green area is going to be 2 root 2 times 1 times 1/2 equals root 2. And then for the pink triangle, we have 2 root 6 times 1 times 1/2, which equals root 6. And then now let's get this rectangle, right? So that rectangle, let's say this point is A, and this point is B, and this point is C. Then that's going to be ACBQ. So ACBQ, this is going to be equal to 2 root 6 times 1. That's just 2 root 6. And so that means the whole of PCRQP, so that thing, that pentagon, that's going to be equal to these 3 summed together. So PCRQ, this is going to be equal to, so that quadrilateral, that's going to be 2 plus 6 plus 2 root 6, which is 3 root 6 plus root 2. So that's a 3 root 6 plus root 2. And then now what we have to do is we have to subtract the value of this triangle. So we have to subtract PRC from this much so that we will get this in-between area, which is actually what we want to get. And so PRC, it's not China, PRC, that's going to be equal to, this much is 2. So it's 2 times, and then this much is 2 root 2 plus 2 root 6. 2 root 2 plus 2 root 6. And then it's a triangle, so divided by 2. So these two are going to cancel. So what we want to do is this minus this. So it's 3 root 6. So 3 root 6 plus root 2 minus 2 root 2 minus 2 root 6. That is just equal to root 6 minus root 2. And that is our answer. It's D. Number 16, the graphs of y equals log 3x, y equals log x of 3, y equals log 1 over 3x, and y equals log x 1 over 3 are plotted on the same set of axes. How many points in the plane with positive x coordinates lie on two or more of the graphs? Okay, so basically, we know that this is like log 3 of x over 1. Sorry, 1 over log 3 of x. And that's just minus log 3 of x. And this is just minus 1 over log 3 of x. And so if we say that log 3 of x, if we just change log 3 of x to be just, let's say it's k, then we're going to have graphs of y equals k, and y equals minus k, and y equals 1 over k, and y equals minus 1 over k. So we are going to actually have things like that. So that's going to be our coordinate plane, and we want positive x coordinates. And so that's why we're only going to be focusing on that part. And if y is k and y is minus k, that's just y is log 3 of x and minus log 3 of x. And so this one is going to look something like that. And then y is minus k, that's going to look something like that. And then y equals 1 over k, that's going to look something like this. And that's going to look something like that. And y is minus 1 over k, that's going to look something like this. So how many intersections? 1, 2, 3, 4, 5 intersection points. This is 5 intersection points. That is our answer. It's D. Number 17, let ABCD be a square. Let EFG and H be the centers, respectively, of equilateral triangles with bases AB, BC, CD, and DA, each exterior to the square. Where's the ratio of the area of square EFGH to the area of square ABCD? Okay, so if we just take out our squares, so that's ABCD. Yeah, so this is going to be A, B, C, D. We are going to have equilateral triangles, each exterior to the square. So if we just draw only one of those, that's going to look something like that. EFGH, and EFGH, they are the centers of those triangles. So this is going to be the center of that, and then if we have one more, then we're going to have that, and that, and that. And so if you see, each will be on this triangle. And so if we just draw all of those triangles, then they're going to look like it's going to be at right there, and it's going to be right there, and right there, and right there. So this is going to be E, this is going to be F, this is going to be G, right? That's going to be G, and this is going to be H. And then we want the area of square EFGH to the area of square ABCD, so that ratio. So now we have to, so we have to get the area of EFGH, or just its side length, because we know the side length of ABCD. And let's say that that one side has length of 2. If that's 2, then we can just drop down this like that. And then we know that this is 2. That's going to be 2. And then we have to take this. So this is going to be, and we're going to use the fact that this is a 30, 60, 90 triangle, because if we have an equilateral triangle like this, and then this is going to be 120 degrees, and this is also going to be 120 degrees, cut it in half, this is 60 degrees, this is 90 degrees, therefore this is a 30, 60, 90 triangle. And so since if this is 2, this is 1, so this is just 1/3 times the height of the equilateral triangle. So this is 1 to root 3, but then this root 3 part is actually 1. So this is actually 1. So this is going to be 1 over root 3, which is just root 3 over 3. And then this part is also going to be root 3 over 3. And so this is going to give us that FH, that's equal to 2 plus 2 root 3 over 3, which is 6 plus 2 root 3 over 3. And then since this will be a 45, 45, 90 triangle, then the ratio will be 1 to root 2. And so if we divide this length by root 2, then we will get the side length. So the side length, EFGH side, let's say just FG, that's going to be a side length like that. It's all over root 2, and then this thing. So 6 plus 2 root 3 over 3 root 2, that's just going to be equal to, that's going to be equal to 3 root 2 plus root 6 over 3. And so the length ratio of EFGH to ABCD, so the length ratio, that is just going to be equal to 3 root 2 plus root 6 over 3, and then 2, this 2. And then so our area ratio, that's just going to be equal to this squared to this squared, right? So that's going to be all over 4, and then this squared is going to be all over 9, and then 24 plus 12 root 3. So this is going to be 36, and then 24 plus 12 root 3, and that is equal to all over 3, and then 2 plus root 3. So this is our answer. It's B. Number 18, for some positive integer n, the number 110 n cubed has 110 positive integer divisors, including 1 and the number 110 n cubed. How many positive integer divisors does the number 81 n to the 4th power have? Okay, so since this has 110 positive integer divisors, and we know that 110 equals 2 times 5 times 11, that means these are the number of factors, and so the exponents, that will be 110, so the exponents of 110 n cubed, this is going to have 2, 5, 11 as the bases, and then 2 minus 1, 5 minus 1, 11 minus 1, so those are going to be the exponents. So that's going to be 1, and then 4, and then 10. Actually, that doesn't really matter because that's just the number of divisors, what we're going to get. And so just 10 for 1, 4, 1, 10, that really doesn't matter. Okay, and so if we do that, then n cubed, this is going to be 1, 1, 1 of each is going to be gone. So it's going to be 2 to the 9th and 5 to the 3rd. So n is going to be 2 to the 3rd, 5 to the 1st. So 81 and 4th. 81 and 4th, this is going to have 3 to the 4th times these to the 4th. So it's going to be 2 to the 12th, 5 to the 4th. And so this is going to be, so this is going to have 4 plus 1, 12 plus 1, 4 plus 1, which is 5 times 13 times 5 factors. And so this is going to be 25 times 13, which is 325. So 325 is the answer. It's D. Number 19, Jerry starts at 0 on the real number line. He tosses a fair coin 8 times. When he gets heads, he moves 1 unit in the positive direction. When he gets tails, he moves 1 unit in the negative direction. The probability that he reaches 4 at some time during this process is A over B, where A and B are relatively prime positive integers. What is A plus B? Okay, so first of all, he can just get 8 heads. We're just going to do casework here because there's not much cases to consider. Or he could get 7 heads and 1 tail. Or he could get 6 heads and 2 tails, or he could get 5 heads and 3 tails, or he could get 4 heads and 4 tails. And this is the last thing possible because he would just barely reach 4 when he goes head, 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 and then tail, 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 tail. This is the only way. So if we just count the number of ways that each thing is possible, for 8 heads, just getting that is 1 way. 4 heads, 4 tails, I just said that it's also 1 way. Head, 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 tail, 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 like that. And then for 7 head, 1 tail, then whatever configuration it's going to go, it's 100% going to go at 4, 0 in some point. So this is just a choose 1. This 2, it is going to go to 4 at some point. So this is just a choose 2. But then this thing, some cases it might go to 4, and some cases it might not. So first thing, it can go to 4 if we have head, 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 head. 4 at the start, and then we don't care what happens next because we've already reached 4. So this is going to be tail, 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 head mixed all together. That's just going to be 4 possibilities. But then if tail goes somewhere at the front, then head, 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 head. That means tail can go either here, 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 or here, and it can't go at the bottom because, and it can go last because that will just be that. And so this is just going to be 4 choices. So 4 plus 4, that's 8 choices. So this is actually 8 choices. And now, if we add these all together, we're going to get 1 plus 8 plus 8 choose 2. What is that? It's 28 plus 8 plus 1. This is equal to 46. 46. And then our total possibilities, that is going to be 2 to the 8th power, which is 256. So it's going to be 46 over 256. So 46 over 256. This is going to be equal to 23 over 128. So this gives us, it's 23 plus 128 equals 151. And so 151 is our answer, it's B. Number 20, a binary operation diamond has the properties that A diamond B diamond C equals A diamond B times C, and A diamond A equals 1 non-zero operate for all non-zero real numbers A, B, and C. Here the dot represents the multiplication. The solution to the equation this thing can be written as P over Q, where P and Q are relatively prime positive integers. What is P plus Q? Okay, so at this you must have, so upon seeing this thing you must have suspected, and upon testing it with here, then you must see, oh yes, that is correct. And what is that? That is the fact that the diamond, this is just actually, that's just the division operation. This is true, and if you do this, then that's also true. So this is just going to be 2016 divided by 6 over x. This is just going to be 2016 over 6x. That's equal to 100. So that means x equals 600 over 2016. And this is just equal to, if we divide by 6 on both sides, then that's going to be 100 over 336. And so that's just equal to 25 over 84. And so this is just, so that's P over Q. So 25 plus 84, that's equal to 109. So 109 is our answer. It's A. Number 21, a quadrilateral is inscribed in a circle of radius 200 root 2. Three of the sides of this quadrilateral have length 200. What is the length of its fourth side? Okay, so if we just bring out the circle, then it's going to look something like that. And then the quadrilateral inscribed inside it, that's going to look something like this. So that's going to be our quadrilateral. And the radius is 200 root 2. So that means that this one's just going to be 200 root 2, 200 root 2, and 200 root 2, because this is the center. And then three of the sides have length 200, so these three will be 200, 200, and 200. And we want the length of its fourth side, and this will be the fourth side of the quadrilateral. So this will be our quadrilateral. And then what we can do now is we can just put lines like there and right there, because those will help us. And since these lengths are equal, we know that these have the same angle, and we see that this angle will be equal to that angle. And because this is an isosceles triangle, because these two are the radii. But then in that case, this and this small triangle is similar, so that's going to be, these are also those blue angles. And because of that, this is also a blue angle. Since this is the same angles for all three of these, that means this is going to be blue too, and this is going to be blue too, and this is going to be blue too, like that. And since we know that blue plus red, so that equals 180 degrees. So for this to equal 180 degrees, that means this must also be a red. So that must be red, and this must also be red. Now we can see that this and this and this, they are just all, so they're all similar, right? And since the length ratio is 200 root 2, 200 root 2, 200, so that's going to be ratio of 1 to root 2 to root 2. And so same thing, 1 to root 2 to root 2. So if this is root 2, then this is also going to be 200, right? So we know that this is 200, and that's going to be 200 times 1 over root 2, which is 100 root 2. And so since this thing is 200 root 2, and this much is 100 root 2, that means this much is equal to 100 root 2. So that's going to be 100 root 2. And same thing, we use the same thing here, 200 root 2, so 1 to root 2 to root 2, that's going to be equal to 1 to root 2 to root 2. So that length is going to be 100 root 2 times 1 over root 2, that's going to be 100, and this is going to be the same thing. And so we want the fourth side, which is this side. That's 200 plus 100 plus 100, sorry, that's not 100, that's 200. So this is 200. And so 200 plus 100 plus 200, that's going to be equal to 500. So this is the fourth side, it's E. Number 22, how many ordered triples x, y, z of positive integers satisfy the LCM of x, y is 72, LCM of x, z is 600, and the LCM of y, z is equal to 900. Okay, so 72, this is just equal to 2 cubed, 3 squared, and 600, that's 2 cubed, 3 times 3 times 5 squared, and 900, that is equal to 2 squared, 3 squared, right, 3 squared, 5 squared. And so if we have x, y, and z, between x and y we're going to have 2 cubed and 3 squared, and since the other one with the y has only 2 squared, that means x is going to have 2 cubed. And then since with the other one without the y there is no 3 cubed, that means y is going to have 3 squared. And then z, the ones with z only, they have 5 squared, so the z is going to have 5 squared. But then here we run into a problem. What about this 2 squared? Because y and z, they're just going to be 3 squared times 5 squared at the minimum, but then this should also be included somewhere. So the problem is where to put that. And so it has to be put in one of these two. So either y or z needs 2 squared. So if y has 2 squared, then z can have 1, or z can have 2, or z can also have 2 squared. But if z has 2 squared, then y can have 2 squared, or y can have 2, or y can have 1. And so this is going to be 5 possibilities. That's going to be 5 possibilities. And then the next one is, what do we do with this 3 over here? Because x and z, they don't have a 3. So x and z, these two will need to share, right? So either one of these two will have to have a 3. So either x can be 3 and z can be 1, or they can both be 3, or x can be 1 and z can be 3. This is 3 possibilities. So if we have 3 and 5, we multiply them together. This is going to be 3 times 5 equals 15 possibilities for everything. So that is our answer. It's A. Number 23. 3 numbers in the interval 0, 1 are chosen independently and at random. What's the probability that the chosen numbers are the side length of a triangle with positive area? Okay, so let's say that the side lengths of a triangle are a and then xy. And let's say a is the longest. So a is greater than or equal to x, a is greater than or equal to y. And so we have to satisfy the triangle inequality because they should be a triangle. That means a has to be less than x plus y. That's true. And then since since x's limit is a and y's limit is also a, then we can just make a graph with x and y. Then their limit is a, so they can only move inside this. They can move only inside the square. But then that's just going to be equal to y is greater than negative x plus a. So if we just graph this, then that's going to look like this. So y is greater than minus x plus a. That means it's going to be in this part. And so our total possible area was this much, but the actual area that is possible, that's this much. So it's 1 over 2. So it's half of the area. So it's half of the area. So that means it's half of the probability. So our answer is just 1 over 2. It's C. Number 24. There is a smallest positive real number a such that there exists a positive real number b such that all the roots of the polynomial this thing are real. In fact, for this value of a, the value of b is unique. What is the value of b? Okay, so first that we notice is that a and b are positive, so this is the actual sign. And these signs are alternating, that means the sum is positive and the product is positive, so this gives us there is alternating sign. So this means all positive roots. So all of them have positive roots. And one more thing, because b is unique, then if b changes, then it should have no longer 3 real roots. Since it has all positive roots, then the things that b, it's either like this, or it's like this, meeting it twice, or it's like this, meeting twice, or it's like this, meeting only once. Let's try to test it for all of these values. If b changes, so if b goes slightly up, then this is going to be something like that. So that's not possible because that still has 3 real roots. And then for this one, if b goes a little down, a little down, then that's going to tilt and go like that. So that's going to have 3 real roots. That's not possible. And for here, if b goes a little up, then it's going to go something like that. And that's 3 real roots, impossible. But this one, however you move it, is all going to just stay at 1. So that is what this is. And since this is like they should have 3 roots at the same point, this means that this is just equal to x minus r cubed. So x minus r cubed equals this thing. It equals x cubed minus ax squared plus bx minus a. And so here, so the sum of the roots is a. So a equals 3r, and the product of the roots is a. So a equals r cubed. So this gives us that r squared equals 3. Therefore, r equals root 3. Since r equals root 3, so it's x minus root 3 cubed. And we want b, which is the coefficient of x to the first power. And so that means b is going to be root 3 squared times 3, which is 3 times 3, which is 9. And so 9 is our answer. It's B. Last problem, number 25. Let k be a positive integer. Bernardo and Sylvia take turns writing and erasing numbers on a blackboard as follows. Bernardo starts by writing the smallest perfect square with k plus 1 digits. Every time Bernardo writes a number, Sylvia erases the last k digits of it. Bernardo then writes the next perfect square. Sylvia erases the last k digits of it, and this process continues until the last two numbers that remain on the board differ by at least 2. Let fk be the smallest positive integer not written on the board. For example, if k is 1, then the numbers that Bernardo writes are like this, and so on. The numbers showing on the board after Sylvia erases are 1, 2, 3, 4, and 6, and thus f1 equals 5. What's the sum of the digits of f2 plus f4 all the way to f2016? Okay, so since Bernardo writes a perfect square, if Bernardo writes m squared, then that means Sylvia will leave m squared over 10 to the 2r power's floor like that. How did such a number occur? This is because, first of all, the 2r, that's because we want f2, f4, f6 all the way to 2016, and this is when r is from 1 to 1008. And so that means first we divide by 10 to the 2r power. Dividing by 10 to the 2r power, this is equal to adding 2r decimal points. Right, so that's just adding 2r decimal points to m squared. So if we have m squared equals 625, then that's just adding 2r decimal points like that. So it's going to be 6.25. And then getting the floor of that, that's just basically cutting off the decimal points, the point after the decimal, decimal. So together, this is just the same thing as erasing 2R digits. The last 2R digits, this is what Sylvia leaves us. Yeah, what Sylvia leaves Bernardo. And then since their numbers have to differ by at least 2, then the next one is going to be m plus 1 squared over 10 to the 2R floor minus m squared over 10 to the 2R floor. This is going to be equal, so that's going to be greater than or equal to 2. And since these are floors, we just know that the things inside of them, are differing by 1 at least. So m plus 1 squared over 10 to the 2r minus m squared over 10 to the 2r, they have a difference of at least 1. So if we just do the square root of that, if we just expand that, these are gonna cancel and give us 2m plus 1. This is greater than 10 to the 2r power. So this gives us that m is greater than 10 to the 2r over 2 minus 1 over 2. And that means if we just add some small value, let's say small value as epsilon, that means m is going to be greater than or equal to 5 times 10 to the 2r minus 1 power plus epsilon. And so then it's no longer going to be greater than or equal to, that's going to be greater than, right? So that's going to be equals, right? M equals 5 times 10 to the 2r minus 1 power plus epsilon. And we know that every time r increases by 1, then that means just epsilon is increasing by 1. And so now that m is this, we can just plug that into this part. And so we will get m squared, so 5 times 10 to the 2r minus 1 power plus epsilon squared over 10 to the 2r power floor. So if we simplify this, then we're going to get that it's the floor of 25 times 10 to the 2r minus 2. Yeah, so it's going to be 10 to the 2r minus 2 plus epsilon squared over 10 to the 2r power. And then we know that these, so that's an integer, because epsilon should be an integer and this should also be an integer. And so that means this is going to be 25 times 10 to the 2r minus 2 plus epsilon plus the floor of epsilon squared over 10 to the 2r, like that. So we find it so when this one does plus 1. So since epsilon is adding 1 each time, then this means that this part is always going to increase by 1. So that part increases by 1, but since it must differ by at least 2, that means that difference must also be at least 1. We can get rid of this part and move this over there. And so this is going to tell us that this difference, the floor of epsilon squared over 10 to the 2r, this difference has to be 1, since they both have to total 2. And so this gives us that the smallest epsilon value is going to be 10 to the rth power. This is the smallest epsilon value. And so if we just plug that into this thing, so if we plug that into here, because that's just going to be 0, because this is going to be the value, if we plug that into here, then that's going to give us 25 times 10 to the 2r minus 2 power plus, and then epsilon is 10 to the rth power. And then here we see that, and we know that r is from 1 to 1008, like that. And so if r is 1, and then we have 25 plus 10. If r is 2, then we have 250 plus 100. If r is 3, then we're going to have 250,000 plus 1,000, like that. And then we see that their sum, so their sum is going to be each number, right? So each number like that will have a sum of 8. Some of the digits are going to be 8 because it's always 2 plus 5 plus 1. And then we have 1008 of these, so we have 1008 of those, so that's 1008 times 8 each. That's going to give us 8064. So 8064, that's our answer, it's E. So that was it for the AMC 12A from the year 2016, and thank you for watching.